is the Virginia-class nuclear-powered submarine. To simplify it for animation purposes, we'll divide it into 5 sections. Section 1, 2, 3, 4, and 5. Section 1 contains one of the major parts like the sonar and the missile's tubes. Section 2 consists of the sail. All this communication equipment retracts from the submarine and initiates the diving process just as shown in the animations. Just below it is the control room and torpedo room. Section 3 is divided into 3 storied. This is where the sailors sleep and eat. And just behind it is the newly added Virginia payload module that holds 28 missiles. Section 4 has the most important parts, the nuclear reactor along with the engine room. And the last part, that is Section 5, consists of the turbines and gears which connects with these propellers. In this video, we're going to explain the complicated process of a nuclear reactor in super basic animation. Not to forget, we're also going to analyze how a submarine fires a missile while still being submerged underwater, and most importantly, how a submarine descends and ascends through the process of buoyancy, all in the videos ahead. So stay tuned and don't miss a beat. This is the Virginia-class attack submarine developed in the 1990s. And some analysts believe it was built to supplement the Sea Wolf fast attack submarine due to the increasingly high price tag of around $3 billion. While the Virginia-class was commissioned at a cost of around $2.5 billion. But adjusted to inflation, the Sea Wolf would cost around $9 billion, while the Virginia-class might cost around $4 billion. Compared to the Russian Akula class, it was commissioned at a cost of around $1.8 billion. All in all, 66 Virginia-class boats were planned to be built, but only 22 were completed. There are different versions of Virginia-class submarines, but let's take this as a base. The latest version commands a length of 460 feet or 140 meters, which is almost the length of 4 basketball courts. Interestingly, the beam is around 35 feet or 10 meters in height. Let's compare this to a person to help us visualize how huge this underwater beast is. Even better, to help us understand its volume, we found out you can fit as many as 80 buses inside this submarine, if all are stacked one on top of the other. That's a lot of school bus parking area for a nuclear-powered submarine. Comparing it with different submarines like this German U-boat built during World War II, it looks a lot smaller. This is the American nuclear Sea Wolf fast attack submarine. Beside it is the Russian Akula-class nuclear-powered submarine. And this last one is one of the biggest, Russian Typhoon class. Also nuclear-powered, built during the Cold War era and still in service today. It weighs around 10,200 tons, which is almost the weight of 41 Air Force One planes, used by the President of America. That's a lot of weight on its shoulder. Still, we should not underestimate its endurance, as it can command a speed of 25 knots or 46 kilometers per hour and over. And it can go to depths of 800 feet or 240 meters. This submarine range is unlimited considering it is nuclear-powered. This is the conformal large aperture sonar array equipped with both active and passive versions of sonars. This is how it works. Active sonar emits pulses of sound waves that travel through the water and reflect off the target and return to the ship. By knowing the speed of sound in water and the time for the sound wave to travel to the target and back, the computers can then quickly calculate the distance between the submarine and the target in a short amount of time. But the Virginia class uses an advanced passive sonar that maps the ocean floors and minefields. Additionally, the sonar array are also attached on each side, along with the long boom array to provide quick target location and information. Just behind the sonar section are the Virginia payload tube outer hatch. 2 of them can be found just besides each other. Inside the tube are 6 Tomahawk missiles. Let's see how this works. Step number 1. A submarine will ascend to an assigned depth. Step number 2. When ready to launch, it will open up the hatch and the protective seal will break open. Step number 3. High pressure and compressed air is pumped into the tubes, and this is used to eject the Tomahawk missiles. Step number 4. The tip of the missile breaks the water's surface. Step number 5. The rocket boosters fire and propel the missile into its path. Boosters fall off as soon as the missile is out of the water. Step number 6. The main engine of the Tomahawk missile will engage and then it will open its wings, just like the animation shown here. Moving ahead is the sail, for size visualization purposes. Let's compare this to the height of a sailor. This is the surface navigation bridge where sailors or commanders stand on top for outside observation. These are the two octronic masts, a sensor on a submarine that functions similarly to a periscope, without requiring a mechanical tube. Moving ahead, this is the communication mast required to send and receive data. At the back is the snork mast. Snorkel is a device which allows a submarine to operate submerged while still taking in air from above the surface. This is the sub-HDR, high data rate satellite communication. But just a reminder, this is no ordinary internet connection. It has a military-grade data encryption level for using the internet because you do not want hackers knowing your submarine position and reading your classified data. But we as civilians can also achieve this level of encryption by using private internet access. Whenever you are browsing online on an unprotected device, such as your phone, computer, tablet, or console, your device is transmitting a great amount of information out into the open, which can be viewed by various different entities before reaching the intended website. A virtual private network, or VPN for short, hides your IP address and safeguards your internet connection through an encrypted tunnel. Taking this guy as a reference, as he is sailing from America to London, his websites and services across the internet will change and accessible depending on his physical location. Here is my account. As you can see, I'm in the UK version of Netflix. To switch to a US server, I just use Private Internet Access VPN. This is a London server, and to switch to a different server, I just have to scroll here and select US Streaming Optimized Server, which is going to be used for streaming content specifically. Then go to our web browser, refresh it, and boom, here we go, Netflix US region. But wait, that's not it. You can now use one private internet access subscription to protect an unlimited amount of devices at the same time, just for the price of one account. Go to piavpn.com/AITele for an 83% discount on private internet access. That's $2.03 a month, and get 4 extra months for free. This is the control room, and it is divided into various sections. This is the ship control department. Interestingly, the sonar section has the highest number of technicians working on it, as they are the eyes and ears, beneath and above the ocean. This is the photonics and navigation department, is digitally linked to the sail, and it can also be described as the modern age periscope known as the photonics. Here lies the radio room. Just beside it is the special operation room, and the last section is the combat and control room that fires the missiles as well as the torpedo. This is how a torpedo works, explained in very basic animation. Step number 1. Pressurized air propels the torpedo toward its target. Step number 2. The piston engine with propellers maximizes the torpedo's speed. Step number 3. It trails a wire plugged into the weapons systems aboard the sub using data to navigate. Step number 4. The torpedo accelerates to 32 knots over 35 miles an hour with a range of 8 miles or 12 kilometers. Step number 5. As it nears its target, the wire is cut and its sonar takes over navigation. Step number 6. If a torpedo misses its target, it can circle back and starts hunting the target with its sonar. This one torpedo has the explosive power of 1,200 pounds of TNT, and I guess you do not want to be at the receiving end of this weapon. But reports suggest that new breed of barracuda torpedo or supercavitating are going to be the latest upgrades. This upper section is the sleeping area of the crew. It has around 119 permanent berths. Just below it is the kitchen, or some call this the galley. It also has a wardroom. In simple words, a dissection where sailors eat lunch, dinner, or conduct mission meetings. Moving to the back is the upgraded Virginia modules, which can hold around 7 missiles. That is around 28 missiles, just with these 4 tubes. And now the most important part is why they called this a nuclear submarine. Nuclear physics is a complicated subject, but we will try to explain the basic process in super simplified animation as shown below. A nuclear reactor consists of 3 crucial components. 1. Fuel elements could be uranium-235 or uranium-238, and these rods vary in number according to the size of the reactor. 2. Moderator here can be water. 3. These are the control rods, and the main function is to absorb any excess or spare neutron in the moderator, that is water. Let's see how it works. Uranium oxide is compressed into fuel. Parts of uranium are packed into sealed fuel rods. The fission of the uranium begins by bombarding it with neutrons. In each fission, 2 or 3 neutrons are released. This in turn causes new fission, and thus creating a chain reaction. But in a nuclear reactor, it's important that this chain reaction is controlled after each fission. Only one released neutron should cause new fission. This is how it is controlled. By lowering the control rods, it absorbs the oversupply of neutrons, lowering all the control rods at the same time, and the result is it helps stop the chain reaction. Now that we have mastered the basic understanding of a nuclear reactor, let's look at the step-by-step process. Step number 1. The nuclear reactor heats the water to 320 degrees Celsius. Step number 2. This pressure regulator is responsible for preventing water from converting into steam. Step number 3. High pressure passes through a steam generator. This is where you want to convert water into high pressure steam. Step number 4. The steam helps turn these huge turbines at a very high speed. Step number 5. The spinning turbines are connected to these gears. Step number 6. The gears and clutch then powers the electric motor. Step number 7. This in turn powers the propellers of this huge underwater beast, propelling at speeds of 25 knots or 46 kilometers per hour. Step number 8. The steam from the turbines is then passed through a motor condenser, which turns into water. It is then pumped back into the steam generator, and the process is repeated, giving it almost an unlimited fuel for the submarine. Now that you have understood the basic of a nuclear reactor, this is how it works in a Virginia-class nuclear submarine. The heat for this nuclear reactor is used to generate steam. This steam is then used to rotate a series of turbines, forcing the blades to turn at a high speed. In a more simplified animation, these then drove the propellers, moving this 10,200 tons underwater beast at a speed of 46 kilometers per hour or 28 miles per hour. This is unlimited energy of about 20 years without needing to refuel, and only limited by the sailors' food supply. Ballast tank technology is a complicated process, but we will present it to you in a super simplified animation. In a submarine, there are ballast tanks attached to both the front and back, and even in the middle. Let's take a look at this submarine cross-section from the front. The tanks have flood ports at the bottom and valves at the top. In order for the submarine to submerge, it opens the flood ports. As soon as the back and front ballast tanks are filled, the submarine will then start to dive or descend just as shown in the animations. In order to move to the surface, air under pressure is pumped into it to blow the water out of the ballast tank, just as shown in the animations. The submarine will rise as a result of buoyancy, which we all know all liquids and gases in the presence of gravity exert an upward force. But that's not it. The submarine also needs to steer. It can turn left or right by using the rudders. These are the elevators of the submarine, present at the back, and they also have a retractable dive planes located at the front. They control the ship's angle, which means they can go up or down. We make original 4K 3D animation from scratch, with a very small team working on it full time. So please support us by subscribing and checking out Private Internet Access VPN, who sponsored our video. Also consider exploring our recent video, the Ocean Gate Titan and the F-16 fighter jet.